close to the current EU standard. I would call this international at the international norms, well below the Chinese standard. That's 70% reduction. And environmental tobacco smoke is even more important. All right, so that's the estimate of exposures. Now again, the exposures come from reduction in outdoor air, but also a change in the sources indoors, and estimates of how much of the outdoor penetrates indoors, and also how much time people spend in each place. Now I should say, I should have written this down, we do not consider occupational exposures here. Some people work in dirty industries, in mines or wherever. They might get very high levels, but we weren't able to model that or estimate that, so it does not include occupational exposures. So what diseases are associated strongly with air pollution? Chronic obstructive pulmonary disease, COPD. I said lung, I should say pulmonary. Two types of cardiovascular disease. Ischemic heart disease, this is the major kind of heart disease that you think of when somebody has a heart attack. Stroke, lung cancer, and acute lower respiratory infections, but only in children. Pneumonia is the most common manifestation of this. In addition, however, a whole set of other diseases are strongly associated with air pollution. Tuberculosis, low birth weight, cognitive effects, lower IQ, a number of other cancers, cataracts, stillbirths, birth defects, and so forth. But in the global burden of disease, and we're saying, you had to really provide good evidence to be able to put the disease above the line, to count it as part of the burden. And so these are the only diseases that were satisfied the criteria for being above the line. All of the risk factors, the people doing smoking, the people doing water and sanitation, the people doing occupational impacts, the people doing dietary, they also had to make the argument, had good enough evidence to put their effect above the line. And these are the ones we ended up with for air pollution. They're all included for smoking, but smoking has many more, but also all of these. The biggest impacts of smoking are the same ones. Maybe if we do the burden of disease again in 5 years, I'm sure a number of these. I'm very sure these first two will be included because we're very close to having enough evidence for TB and low birth weight, and maybe some of the others too. But right now, we're only talking about these. But this is not all that we know about from the health effects of air pollution. So now the integrated exposure response curves I mentioned, here they are for these 5 diseases. And here's the exposure, annual exposure, and there's the relative risk. So those of you who are not familiar with the term relative risk, it means that somebody at, say, 3, that's so, what is that one? That's pneumonia. So a child living at 380 micrograms per cubic meter would have 3 times the pneumonia rate as a child living down here, and the counterfactual here is 12. We use the EPA standard as the counterfactual level. Now you notice these curves are quite different from one another. I think some are similar. These two are sort of similar in shape, but others are quite different. This one, the lung cancer one, is very linear. So you drop from here, you decrease your exposure by half, you get roughly half the risk. But some of the others, like stroke, is very nonlinear. So if you're up here and you reduce air pollution a little bit, you don't get much benefit in terms of health. You have to start down, you have to get pretty clean before you get a benefit for stroke. It says profound implications for policy. Now, it's different depending on which disease you look at, but we're taking, a total disability valley approach, total premature death approach, which basically adds up the effect across all of these diseases. So our software, basically calculates all of these separately and then combines the results together. So, for some, like heart disease and stroke, you have this long flat area here. For others, there's more, lung cancer is very linear, and the others go in between. I'd be glad to talk more about this to those of you interested in these kinds of things after lunch. So what do we find? Well, first, deaths averted. Remember, in spite of the motto at the Johns Hopkins School of Public Health, which says, what is it? Averting deaths by the millions. You can't actually avert a death. I mean, does anybody here plan not to die? But you can delay deaths. You can only stop premature deaths, you can't stop death. So this is a premature death. And so over the 10-year period, then scenario 1, you know, we estimate you to avert about 1,000 deaths. And in scenario 2, I'm getting up close to 3,000. And you can see that the deaths are dominated by heart disease, stroke, and pneumonia. The lung cancer and COPD are less important. If you look at it in terms of dollars, here is a business as usual, a slow increase in the amount of ill health created by air pollution in the city, in spite of, you know, planned interventions. And scenario 1 more or less keeps things the same, basically just keeps up with the increase in economic activity and population. Only with scenario 2 do you start seeing a reduction in the ill health in the city. Now we consider this our primary figure. It's in the executive summary. Because it makes the point that you need, which is my bottom line, but I might as well tell you, you need a very aggressive controls in the city in order to improve health. You can do this on a per capita basis. Here is the population, estimated population growth, almost a 40% increase in population in the city in 10 years. And on a per capita basis, you don't get the business as usual stays about even. You do get a reduction on a per capita basis with scenario 1, but an even greater reduction in scenario 2. So this is the population growth. This is business as usual. So the per capita risk is about the same. You do get a reduction per capita, but not in total. This distance is about equal to this distance, as you saw in the previous graph. You need to go to the aggressive interventions in order to get a significant impact improvement per capita basis. So conclusions. The mandate for this assessment did not include evaluation of the cost of reducing pollution under the 2 scenarios, but this would obviously have to be considered. The team points out, however, that if all the measures considered are that all of them are technically feasible and not unusual around the world, not as if we're projecting technologies that don't exist. And I did this. This is not in the report, but I thought you'd be of interest in this morning. This is the WHO has a criteria called WHO Choice that tells you how much you ought to be able to should be able to spend per Delhi to improve health, and that varies by country. Rich countries can spend more per Delhi, poor countries can spend less. This uses the per capita income in Mongolia, which is what they recommend, and you can see that this is the amount that you ought to spend each year under scenario 1 and scenario 2. And so by the 2024, you ought to be willing to spend $140 million a year just for the health benefits. Or I put it total, here's scenario 1 and here's scenario 2, about $600 million, US dollars, over the period to obtain these health benefits. Now that's not the same thing as the economic, my student put that title on it, it's not quite correct. This doesn't include the increase in economic activity and lost work and fewer work days lost and medical costs and all of that. That's a different kind of calculation. We haven't done that. This is just using the WHO WHO Choice, it's called, criteria. How much you ought to be willing to spend to reduce the value. That's a lot of money. Might allow a lot of good controls to be put in. Now, those of you in health, even, or certainly environmental health, every environmental health textbook has the story of the great London smog in 1952, which there was heavy pollution in the winter, coal smoke just stuck around, didn't go away, just sat there for days on end. It was so bad you needed a light in front of your cars as you went down the streets. Thousands of people were killed. Estimates vary, 4,000 to 10,000 in a few weeks, extra people. That initiative, that incident is caused, that is usually initiated the modern era of air pollution control around the world, and certainly stimulated London itself to take very aggressive measures. The result was that London became one of the cleanest large cities in the world in a few decades. They went from one of the dirtiest places in the world to one of the cleanest with aggressive measures. And what was the main cause of that pollution in 1952? It was household heating with coal. That sound familiar? Now, London had a harder job than UB. It's a much bigger city, bigger industrial base. It had pollution coming in from other cities nearby. It was 60, 70 years ago. 60 years ago, you know, technologies were not as well developed. Our understanding of everything was not as well developed. UB ought to be able to do this too. This is, London did this. This is a reduction in the air pollution. And one of the ways, main ways they do it was by doing this. Look at household coal. Household coal disappeared. You cannot burn coal clean enough at the household level to really protect people's health. They tried introducing clean coals and improved stoves, and they gave up. They just got rid of household coal. Now, Mongolia, you know, used to look all like this. You know, and being here a few times and talking to people and sitting around drinking at restaurants, you know, I think there's a kind of a nostalgia for this old time. People go out, they have their second homes, or they go out into these gurs out in the countryside. You know, and I must say, it's attractive. It's a really beautiful country. And in those days, a few solid fuel homes, so this is probably wood, not coal, but still solid fuel, I mean, it didn't matter. You know, it didn't cause any problems. Actually, let me ask, how many people know where this is a painting, I took a picture of it. Anybody know where this painting is? I bet you've all seen it, almost all of it. It's only 200 meters from here. It's in the lobby of the Ministry of Health around the corner. This is the old days. But that's not today. This is today. A clean day today, but that's where more than half the population live today. They can't have solid fuel stoves. When everybody, you know, with other stove, people are 5 kilometers apart. Here they're, you know, 10 meters apart. It's not possible anymore. It leads to this. Hundreds of thousands of coal stoves in Ulaanbaatar lead to this in the winter. And hundreds of unnecessary premature deaths every year. Conclusion, if aggressive action is taken, as in scenario 2, an average of 1 premature death per day can be prevented every day for the next 10 years. And then, you know, of course, with protective conditions after that, for everybody after that, compared to business as usual. That's just for the next 10 years. Leaving UB as one of the cleaner large cities in Asia. Finally, we'll make another point. UB is unique among many polluted Asian cities, perhaps all of them actually, because it has clean areas on all sides. You don't have pollution coming into UB, like London did. Now, you don't know if you know the story of the Beijing Olympics. A year before the Olympics, in August 2007, my colleagues who ran this experiment, they decided to see how much they control air pollution in August. So they clamped down on vehicle use and industries and everything else in Beijing, and they didn't change the air pollution in Beijing much. Why was that? Because much of the pollution is coming from elsewhere. So in 2008, they not only, to reduce the air pollution during the Olympics, they not only controlled air pollution in Beijing, they had to control air pollution in all the cities in the North China Basin. A much bigger effort. You have your fate in your own hands. You control your air pollution. The emission sources, you'll control your own air pollution. You don't have pollution coming in from Tianjin or some other big city in the air basin. This is fairly unique, actually. Here, for example, is a satellite data that has been interpreted for PM 2.5, and notice the pollution, the high pollution levels in the big river valleys of India and China. You can't even see the cities in there. Cities are in there, but it's not just the cities. There's a lot of rural sources. Brick kilns and agricultural burning and power plants and industries that have been shoved out of cities, out of the rural areas. The whole air basins are polluted. Delhi, Beijing, they can't solve their own air pollution problems. Hong Kong can't solve its own air pollution problems. Most of its air pollution now is coming from Guangzhou. UB doesn't have this situation. It's almost like they're out in the middle of the ocean. They can't solve their own air pollution problem. But outside of UB, in comparison, is still relatively clean. Maybe not quite as idyllic as this, but still relatively clean. Mongolia is the least densely populated country in the world. And it's becoming less densely populated, outside the city because people are moving outside the city. You can take advantage of that in improving the situation here. So, final slide. Recommendation, given that the major health impacts that exist today from air pollution and the results, we recommend you need to take aggressive action. If you're actually going to have any improvement in exposure, any improvement in health, any improvement in outdoor air pollution, no matter how you look at it, modest things aren't going to work. So we urge serious consideration by the authorities to take aggressive action soon. Now, it wasn't our job to lay out the ways to do that, but just this morning I was talking to a colleague here from MCS, and I learned that the facility that they were talking about last year is now actually nearing the beginning of construction, and approval permits are coming, and financing is available. Produced 100,000 tons of DME from coal by 2018. That's enough to heat half the houses in Ulaanbaatar. DME is a completely clean fuel made from coal. Some people call it synthetic LPG. That's just one alternative for clean fuels. The biggest single thing that has to be done in order to follow that aggressive scenario is to get rid of coal in households. So this assessment was done in a truly collaborative effort, as I mentioned, by the principal investigators we just heard from, but by a quite competent team. My doctoral student, Drew Hill, who really held the whole thing together, did a lot of the calculations and kept track of all the moving parts. People here in Mongolia that followed the whole thing, gathered the local data, and cleaned it and made it available and so forth. Colleague Rufus Edwards, who did the measurements in households last year and participated in the exposure assessment, and Washington University, Jay Turner, who did the outdoor air pollution modeling. So I want to thank you very much, and we're glad to, I don't know exactly what our schedule is. Maybe we can take a few questions now.